Alright, so star review homework. It's been a while since I've done this, so mind my bad handwriting. As long as you follow along, it should be alright. I would pause before each question, try to do it yourself. So that way you're not just copying answers, you're actually just checking the work you did. But I'm not there, so I can't see how you're doing. Let's just start. So number one, we produced 3.5 billion tons of cement. This is probably important. That amount could increase by a billion tons more by 2050. Express that amount in scientific notation and tell, oh, it says me, I don't know who me is, tell how much larger it is compared to this other number. Alright, so first we need to start off with what's the number we care about. It's not 3.5 billion because we're saying we're going to increase that by a billion more, which might as well just say 1 billion more by 2050. So 3.5 plus 1 more would be 5 or 4.5 billion with the B. Alright, we need to express that in scientific notation. So first things first, we need to know how many zeros makes up a billion. So if we think of place value, the first 3 zeros gets us to 1,000. The next 3 gets us to 1 million. So this would be millions, 10 millions, 100 millions, but that's actually a number. 0.5 billion is 500 million, comma. And the next one is our 4 billion. Those are billions place value. Okay, so there's 4.5 billion. Then we need it in scientific notation. So we're just going to immediately put the decimal back. So we need a number between 1 and 10. And then we need to see how far did our decimal move. So 4.5 is always times 10. So we have 3, 6, 9 decimal places here. So 4.5 million would be 4.5 times 10 to the 9th. There's our first part here. And tell how much larger it is compared to 1.5 times 10 to the 7th. Okay. So we can't really compare it adding wise. That's not how this works. So we have to look at how many times bigger it is. So we can say to get from 1.5 to 4.5 would be times 3. Okay. And then over here, 10 to the 9th compared to 10 to the 7th means that there's 2 extra times 10s. Right? So we can say this is 3 times 10, and either times 10 again or just 10 to the 2nd power. So really it's just the difference between this power and this one. So 3 times 10 squared, that just works out to 300. So our full answer tells us how much larger. 4.5, that number is 300 times as large, or times larger, depending on how you want to phrase it. Here is answer number 1. Okay, 9 to go. And I'm going to tell you these first couple are the most time consuming. They go a lot quicker once we get through here. Alright, so this is the most entertaining of the problems. Just in concept, not the actual math. Large rectangular field. So it's a rectangle. 600 feet by 9,600 inches. So right there should tip you off that this is going to be a pain because we have feet and inches. Right, approximately how many yards? Okay, so this is getting even worse. Now we have feet, inches, and yards. Would a sidewalk need to be installed across the field from one corner to the opposite diagonal corner? So here's what entertains me about this is you have a field and it's large. It tells us it's large. So in the most American way possible, instead of building the sidewalk around the field like you would expect, it's saying we're going to go from one corner to the opposite diagonal corner. How efficient is that? So who needs all this grassy area? We can put this nice cement walkway so people don't have to walk as far to get through the park. Thoughtful. Alright, so our big issue here is our conversions. We have feet, inches, and yards. So let's start the smallest. 12 inches is equal to 1 foot. And then 3 feet makes 1 yard. And so then we can combine these two. There's 12 inches and 1 foot. So 3 feet would have 12 times 3 inches, which is 36 inches to make 1 yard. Okay, so 900 feet would be, or not 900, 600 feet, excuse me, 600 feet to yards. So 600 divided by 3 would give us 200. So we'd say one of our dimensions is 200 yards. And then 9,600 inches. So 9,600 divided by 36. And if you put that into your calculator, you get 266.6 repeating. So we can round that off to 267 yards. My calculator was messing up my pen here somehow, so I did all my calculations off screen, so you're just going to have to take my word for it. Or do it yourself, whatever. Alright, so now we want to know this third length here, and hopefully we recognize, because we talked about it not too long ago, that this would be a right triangle, and the side across from the right angle on a right triangle we can label C, and then our two legs as A and B, and then use our Pythagorean theorem that says A squared plus B squared equals C squared, right? Fill in our numbers. 200 and 267 are both legs, sort of interchangeable, but we can say 200 squared plus 267 squared. And if you wanted to leave that as a decimal, that's fine. Answers will look a little bit different, but not enough to really matter. 200 squared plus 267 squared, and we add all that up, that gives us 111,289. Again, you can either work that out or you can just trust me. We don't want that. That doesn't make any sense in the context of our problem. We need the square root of that to get rid of this square on top of C, so because all we want is just C. The square root of 111,289 comes out to about 334. So our final answer here, what is the total length of our sidewalk? We can say it's about 334. If you said 333, that's also good. It's about 334 yards. Okay. That's a nice ruined parkway. Alright, number 3. Cylindrical can of frozen orange juice has a diameter 6, height 10. Cans are sold, should be D, I guess here, in 6 packs for $3.49. What is the area of the label of the can measured in meters? So again, they're being kind of obnoxious with us, going from centimeters to meters, but that's okay. And I found one place where this case actually existed. They sell them at what was I think it was Costco, which we don't even have here, so I couldn't get an actual price. We're going to assume that's probably true. So really the price doesn't matter. All I want is area of the label. So we just want this nice orange juice label. So this price doesn't matter. It doesn't actually matter that it comes in a 6-pack because it just wants the label of the can, meaning one can. So really we just care about one of these, right? Area, but it's 3-dimensional, so we're actually talking about surface area. And if you consider the fact that it's a label, there is no label on the top, there is no label on the bottom, it's just around the middle, so we're actually looking at lateral surface area. And then because it says it's a can is inherently a cylinder. So really we're looking for lateral surface area of a cylinder. And again, I apologize for my handwriting. Let me see if I can make this a little bit prettier. Oh, look at that. It's like magic. Alright, so we go to our formula chart. Lateral surface area of a cylinder. It's not that bad. It's just 2 pi r h, where pi is going to be 3.14, and 2 is going to just be a number. Right, 3.14 for pi. So now here's the part where we have to think a little bit. So 100 centimeters equals 1 meter. I'm not sure why I wrote that out. That's just 1 m. So to go from 100 to 1, which what makes the metric system a whole lot nicer than what we use, all we have to do is take this decimal and move it back 2 places, right? So if you think about it, how do you get from 100 to 1? You just move the decimal back 2 places. Simple. So 6 centimeters would be 0.06 meters. That's diameter, right? So all the way across here would be 0.06, but we just want the radius, which is half of that, so that's just going to be 0.03. Okay, and then our height, 10 centimeters, same thing. Oh, I don't know why I underlined it. It's just going to get in the way. So take our decimal and move it back 2 places. So 10 centimeters is the same as 0.10 meters or 0.1 meters, and that represents our height here, 0.1. So we can add that to our equation here, and that will give us our surface area. And when we work this out, we'll get a relatively small number because we'll change this to meters, and 1 square meter is actually pretty big, and this label is not big at all. So this actually comes out to, when you put in your calculator, 0.01884 meters. And areas in 2 dimensions, that is meters squared. And I can probably make some of these up. Oh, I guess I'm going to remake all these numbers a little nicer. Ideally, 0, 1, 8, 8, 4. Yeah, you get the idea. Okay, so there's our answer. And if you wanted to, if the question said for some reason what's the area of the whole pack of them, you could then take this and multiply by 6. But it doesn't, so we won't. Alright, number 4. Which statement's true regarding the square root of 85? So first we need to figure out what is actually the square root of 85. And that will come out to, put it in your calculator, that's about approximately 9.2. So does it lie between 9 and 10? Yes. Its value is more than 9 squared. This is the one that's kind of tricky there, because you're like, oh, well, it's just more than 9, 9.2, right? But you got to think, 9 squared is actually equal to 81. So is 9.2 greater than 81? No, not even close. This is not true. They're just trying to trick you there by the way it looks and just the number itself, not caring about the exponent. And its value is less than the square root of 64 plus the square root of 49. Well, square root of 84 is 8 plus 49 is 7. So is it less than 15? So square root of 85, is that less than these two added together? The answer is yes. Okay, so our first and third. I guess you can circle them or something. I don't know. Let's see. If a graph describes the volume of a balloon losing air at a constant rate, this is important, in terms of the number of seconds the air escapes, the x-intercept tells you the number of blank the balloon took to blank. Right? I guess our graph's going to be red. So what is this graph comparing? We don't have any numbers, but that's okay. So we have an x, y-axis. We're talking about losing air, right? So one of our axes should be air, and the other one is seconds, so something in time. So time is almost always independent, so we can say this is going to be seconds down here, which makes this the volume of air. Okay, so if this is 0 air and 0 seconds, that's our origin, right? But that's not actually a point, so don't make point there. When the balloon starts out, you can imagine a balloon that's filled up, the air is at some maximum, right? And then as you let it out, it's going to decrease, right? And it says constant rate, so it's going to be linear, and at some point it's going to stop because it's just going to run out of air. Okay, so our x-intercept is this point right here, which tells us the number of what? What are we measuring? We're measuring seconds the balloon took to, and we could say run out of air, or since everyone's favorite little made-up football thing is to talk about how things deflate. Ha ha ha, how funny. Okay, so in case you're not sure how this works, just because, I don't know, you never got invited to a party, let's let me show you an example here. Okay, you might have to turn the volume up because it says quietly, but here's our balloon, and let's see what happens. And watch, measure your time and the size. Okay, ready? Here we go. Oh, there it goes. That is the air going out of a balloon. Okay, this has 8,000 views on YouTube. I must be doing something wrong. Or something. Whatever. Alright, that's 5. Moving on. Price of cereal varies directly with number of ounces purchased. What is the direct variation equation which matches this scenario? If O is ounces and C is cost. Okay, so varies directly. All that means is our equation is going to look like y equals kx. K is just some number. Y and x are two variables. Okay. There can't be any plus or minus, which means this is a proportional. And it's also proportional. Spelled that right. Linear equation. Okay. So we just need to replace our variables for y and x here. So which of these is dependent? What do we get to choose? Do we choose how many ounces we want or the cost? The answer, hopefully somewhat obvious, is number of ounces. That's a O for the letter O, which means that this is what we choose, and depending on how many ounces we buy, the cost will change. And all that leaves is our slope here, which is the rate of change, which they don't give it a variable, but if you want a determined cost of something, it's number of ounces times whatever the price is per ounce, and it doesn't really give us anything there, so we can just leave it as K. So C equals K times O. And that's it. That's all we can really do with this one. There's no numbers to work with. Alright, number 7. Y is a set of ordered pairs not a function. Okay, so if it's not a function, that means that x does repeat, right? Because for it to be a function, x does not repeat. So since it says not a function, x does repeat. So where does x repeat? Right there. So why is it not a function? X does repeat 0 and 0. You're done. That's all you gotta do. Okay, number 8. Which of these can be best described by a linear function? So linear function needs to look something like y equals mx plus b. So most importantly, to make it linear, there should be no exponents. Ugh, this handwriting. I gotta practice. So no exponents. If there's exponents, it's not linear anymore. So let's look what we got. Area of a circle. Go to your formula chart. Area of a circle says a equals pi r squared. So right there, this is an exponent. Since there's an exponent, this is not linear. So this cannot be the answer. Okay, circumference of a circle. Go back to your formula chart. Circumference of a circle says 2 pi r, or c equals pi times diameter. Did we see any exponents? Well, no. So is it linear? Does it follow this? Yes, it doesn't have any plus b. There's no y-intercept, but it's still linear. So this one is looking good. Okay, and then volume of a cylinder with radius r. So back to the formula chart, volume of a cylinder, area of the base times height. Area of the base on a circle, so the cylinder has a circle base. This would be pi r squared times height. Well, if pi r squared didn't work here, it's definitely not going to work down here either, because there's that exponent, and we said pretty clearly there are no exponents in linear functions. So volume is not linear either. So our answer is this middle one, circumference. That's it. Alright, number 9. Y equals x squared plus 7 is true. Is the following true as well? Dependent variable y is equal to 7 less than the square of the independent variable x. So there's some extra words in here. It says dependent variable y. I mean, y is the dependent variable, but that doesn't really matter here. So y is equal to 7 less than the square of the independent. Same thing here. Independent is x, but who really cares? The square of x. So let's just write this out. So y equals 7 less than x squared. So x squared, and then 7 less than that, so minus 7. So does x squared plus 7, is that the same as x squared minus 7? And hopefully your answer to that is obviously no, comma, duh. Okay. Right? This is your bonus points right here. I need to see this word in this answer for number 9. Okay? That way I know you were here. It'll be our secret. Don't tell anyone. Alright, last one. Bonus points. Go get those points. Which of the following algebraic... No. What is the following algebraic form telling us? So xy goes to ax, ay. So algebraic form, this is talking about transformations. Transformations. Alright. So when we looked at the benchmark, we talked about when we translate, you took x and y and you added something to it. But we're not adding here. So which transformation had to do with multiplying? That's right. Assuming you said it out loud just now, it is a dilation. Anytime you see x and it's being multiplied by something and y is being multiplied by that same something, you're always doing a dilation. And we can get more specific. We could say with a scale factor of a. Because a represents some number. We don't know what that number is. It's just a number. So scale factor is a. And you can replace that with whatever number you want. And that's it. There's 10 answers for 10 questions. That's a nice, easy 100. Alright, so now that you're done watching this, go watch some more some balloons being deflated, or whatever you kids do when you're not doing math. Alright. Good night.